can also yeah.
No, where you going?
I don't know. I don't so much. Oh, this weather's blowing. I was hoping it would have been nice Friday. You know, just the rain in there all day Friday. That's warmer. I know. I'm walking around my car. It's going to rain. I know. Yeah. Hey, man, it is November. We can't complain. Okay, Brad. Hey, Brad, are you ready? What blue's over here? Blue's over here. Hey, Brad, are you ready? Here we go. Let's make this a little bigger so we can all see it. Dun, dun, dun. That's yellow. Whoa. 6 factors that determine the formation of the landscape in a given area. You're running out of sand. Red, you are out of time. Orange, can you feel it? Right up front. You're running out of time, Orange. Orange, you're out of time. Of course, you guys know what that means. That question goes back in the deck. Yeah, okay, Orange. Here is your regular question. Earthquake energy blank when going through less dense materials, so spends blank time causing ground motion. This contributes to creating blank damage. Oh God, yeah, go ahead. I'll be back. Give me somewhere up there. Yeah, I wish I could. So, yeah. Orange, I need an answer. Sorry, you are out of time. Yellow, can you feel it?
It's in 8:38. Less time.
Slower, less increasing.
That's your answer?
Faster, more, decrease.
Okay, what's your final answer?
Under the dense material, it's
faster through dense materials, right?
Well, it's going to less dense.
Oh, okay.
going to be less dense.
More
So,
and less.
Less damage.
so what is it?
Slower, more, and less.
That's it.
Slower earthquake energy, slower, we're going through less dense materials, so spends more time causing ground motion. This contributes to creating less damage.
Decrease in damage.
Increasing damage. Yeah, I flipped it on it. So earthquake energy slows down. It's not going that fast. Think of when you get caught in traffic. If you're caught in traffic, you going anywhere? No, you're sitting in the same spot for 10 minutes. Okay? So if you have earthquake energy that's moving slowly, it's going to stay in the same place longer. The longer it's there, the more shaking it's going to result. So your damage is going to be greater. One very hard-won point for yellow.
Thank you.
Okay, yellow, here's your regular question. Some elements are removed from the parent rock. You're in orange here. Some elements are removed from the parent rock and or some new elements are carried in, both resulting in the formation of new minerals not original to the parent rock. This result of metamorphism is a change in composition of the parent rock and is called what? I need an answer, y'all. I'm sorry, yellow, you are out of time. Green, can you steal it? Can you close the door, please? Can you steal it, green? You're going to need an answer. Oh, I know. You guys are going to be studying for the final. Sorry, Green, you're out of time. Oh, that's going to have to go right now. Okay, we're almost through on our first round and we've only answered one question. Okay, let's warm up. Here we go, Green. Here's your regular question. What type of mountains form at a divergent plate boundary? Continental drifting. Fault block, and what else? Sorry, that's incorrect. Oh, man. Blue. Can you feel it? Okay, fault block. And now that would be fault block. Okay, so what kind of mountains in addition to fault block? Volcanic. Now, when you get the crust separating, it's going to let the magma out. So divergent boundary, you can get faulting, you can get fault block or block fault mountains, and volcanic mountains. Yes. Okay. That's okay. It took my Monday, Wednesday, Friday class a bit longer to warm up yesterday, too. Okay, Blue, here's your question. What is orogeny? What is it, Blue? What's it mean?
Process or sequence of processes that result in the formation of mountains.
Yes, orogeny means mountain building. Okay, Blue's on a roll. Okay, Red, here you go. What type of earthquakes occur at transform plate boundaries? The answer, strike slip. Okay, strike slip fault, so what types of earthquakes? Shallow. Alright. Just in the nick of time. Okay, orange. What is stress? This activity. What is stress? What is stress? Now, these questions and answers are on e-learning, so You want something to help you quiz yourself with the final.
Force acting on an object or material.
Stress is force acting on an object or a material. Also force acting on an area, yes. Okay, see, now we're warming up. Okay, yellow. Oh. Grab it. Right here. Yellow. Oh, well, that's interesting. What are the three types of stress?
Compression, tension, and shear.
Compression, tension, and shear. Yes. Okay, now we're cooking with gas. Okay, Green. List 4 earthquake hazards.
Ground motion, landslide, liquefaction, and tsunami.
Yes, that'll work.
Whatever.
That'll work. All right, yellow. On the board. Okay, Green. We ready? Following characteristics describe what specific type of mass wasting event. Regolith, especially soil, continuous movement of a usually cohesive mass of material, very, very slow, only noticed after years of movement have caused visible damage associated with freeze-thaw cycles. Green?
Green?
Oh,
Hold on, yeah, wait a minute, I think you got mixed up.
I think I did.
Did you just say yellow a second ago?
Yeah, we just did yellow.
Yeah, you just did yellow.
Yeah.
And then-
We just did it last week.
Well, okay, all right.
Sorry,
Oh, this is blue then. That's okay.
All right,
Blue, this is your clever blue. It's Monday for all of us. I know.
First slide.
I'm sorry, that's incorrect. Red, can you seal it? Creek. Yes, that is creek. Okay. Red, here's your regular question. What is the difference between focus and epicenter?
The focus is the location, region, spot on the fault where the rock broke loose and released energy, and the epicenter is the location on the ground surface directly above the focus.
Yes, very good. Yeah. No one-word answer on that one. Okay. Orange. Let me get it on here so you can see it with the hand out of it. What type of dip-slip fault is shown in this figure? And which side is the hanging wall, A or B? That is a reverse fault.
And the hanging wall is on the right.
Which is A or B? B. Yes. Okay. All right, yellow. Huh, that's on. What is strain? Sorry, yellow, you were out of time. Green, can you feel it?
The result of stress recognized as deformation.
Yes, strain is the result of stress. Recognized as deformation. Yes. Okay, Green, here is your regular question. In metamorphism, what is the original rock called? Parent rock.
That was Darren.
What do we know? Okay, blue. Ooh, there you go, sauce. What is isopropy?
Equilibrium between Earth's lithosphere and its
Yes, equilibrium between the lithosphere and the asthenosphere. Yes. All right, red. What are the two main categories or types of fault? Strike slip and dip slip, yes. See, breakfast is kicking in. Breakfast. And isn't it awesome now that McDonald's has 24-hour breakfast?
It's a liar.
Well, it's not a
Whole menu, that's
I know. Okay, you know, I'm down here at 10 o'clock, I think it's Okay. I know, well, they're doing what they can. They're doing what they should have done 40 years ago. Okay, whose turn is it? Who answered the last question? Who answered the last question? Oh, this is yours, right? No, orange. It's orange. Okay, well, okay, orange. Here we go. What are the 4 criteria used to classify mass wasting events? Got time. Yellow, can you seal it?
I think so. Type of material involved,
Yeah, there's one.
velocity of the material, character of the moving mass, is it wet or dry, the environment in which the moving takes place.
Right, so where, what, how fast, and how to move. Yes. Okay, yellow. Here is your regular question, yellow, all nicely shuffled. What type of earthquakes occur at divergent eddy boundaries?
What the movement? Normal faults, shallow quakes.
Shallow quakes on normal faults. Yes.
It just found.
Okay, green. What type of metamorphism occur at transform plate boundaries? Dynamic, yes. Dynamic. Okay, blue. Ooh, big one. The following characteristics describe what specific type of mass wasting event. Regolith, especially water-soaked, fine-grained sediment and or soil. Movement of water-soaked soil, fine-grained regolith and or volcanic ash. Often fast. Usually follow pre-existing stream valleys. Thank you. That was a long one. All right, red. What type of dip-slip fault is shown in this figure, and which side is the hanging wall, C or D?
Small, and the hanging wall can be D.
Normal fault, and the hanging wall is D. Yes. Orange, here you go. Alignment of grains or crystals in a common direction produces thin layers or bands. This result of metamorphism is a change in texture of the parent rock. It's called what? delineation, yes. Okay. Yellow. Oh, well, here's an alternate. What type of earthquakes occur at convergent plate boundaries with subduction?
Shallow near coast,
And,
medium inland, deep further in.
okay.
What have we got on
Is
that?
that called anything special?
Near coast. Oh, is that the Benioff? I can't pronounce it. Benioff.
The Wadaki
Yeah,
Benioff zone, yes. Where you get shallow to medium to deep quakes as that plate descends. Yes. Okay. Alright, catching up with everybody here. Take green. What is an index mineral?
Minerals that start as indicated metamorphic grade.
It's a mineral that does serve as an indicator of metamorphic grade. What else? Why is it able to do that? I'm sorry, you're out of time. Blue, can you steal it?
Index minerals form at specific temperatures and pressure and indicate the severity of metamorphism.
Right. Index minerals are able to determine the severity of metamorphism because they form under conditions of specific temperature and pressure. You guys are half. You have half of it. Okay. All right, Blue, here's your regular question. Don't yell at me, I just shuffle it. Following characteristics describe what specific type of mass wasting event. Usually regolith and or fully consolidated rocks. Mass and material rotates as it moves, causing surface features to tilt towards the top of the slope, often forms a scarp at the top of the slope, and materials are rotated. Curved slide, yes, that often takes slump or rotational slide, yes. Oh, no. So pick it up. Okay, Red. What are the 5 causes of metamorphism?
Increased temperature, increased electrostatic pressure, heat and pressure increase, stress, and circulation of hot fluids.
Yes. All right. Orange. What are the 3 main types or categories of mass wasting? Falls, slides, and flows. Yes. Oh, that was picking up. Okay, yellow. How do metamorphic rocks form?
Cooling of other rocks.
How do metamorphic rocks form?
Form from the alteration of other pre-existing rocks.
Yes. Metamorphic rocks form from the alteration of rocks that you already had. Yes. Hey, green. Ooh, this was a stumper yesterday. How does water contribute to A, increasing shear strength and resisting forces, and B, decreasing shear strength and resisting forces? I'm sorry, green, you're out of time. Blue, can you steal it?
increase in shear strength and resisting forces, if you're going to increase it, then it would be from saturation of the surfaces, whereas decreasing would be from increasing flow, increase of the force causing the movement of the forces.
I'm sorry, this is incorrect. That's good, that's going back in the deck. All right, Blue. Sorry, you lost the chip, but here's your regular question. Of course you do. The answer wrong. Oh, no. All right, here's your regular question. What type of mountains form in a convergent plate boundary with collision? I'm sorry, that is incorrect. Red, can you steal it? Red, I'm sorry, you're out of time. Oh, I've got to go back in the textbook. Okay, Red, here's your regular question. What is the ultimate cause of all mass wastage?
Gravity.
I don't even think any sand fell out of here yet. Okay, Orange. Here we go. What are the three types of strain?
Brittle, ductile, and elastic.
Okay, brittle fracture, what did you go?
Brittle, ductile, and elastic.
Brittle fracture, ductile, and elastic, yes. Snatch in with the orange. Okay, y'all. What are the 6 most common methods or strategies for helping to lessen the potential for mass wasting, thus protecting lives and property? That sounds like a whole question.
Sounds like revegetation of the land.
Yeah.
Regrading of the slope, not to exceed the angle.
Yeah, just give me the list.
Reducing the subsurface water.
Yeah.
Preventing undercutting.
Yeah.
Constructing safety structures.
Yeah.
Controlled blasting.
Yes. Okay. So regrading, revegetating, removing the water, the drainage, preventing undercutting, artificial structures for support, and controlled blasting. Yes. Okay. All right, Green, here you go. You can do it. What is shear strength?
The resisting against sliding.
Yes. Resistance against sliding. Okay. All right, Blue. What are the 6 factors that determine the formation of the landscape in a given area? That's one question.
Transporting agents, release, climate, substrate composition, like activity.
Yes. Okay. All right. All right. Now we're cooking with gas. Okay, Red. Rearrangement of the Blue's glad I didn't get this one. Rearrangement of the atoms in a mineral's crystal structure to form a new mineral with the same composition, but with a differently shaped crystal structure. This result of metamorphism is a change in texture of the parent rock, and is called what?
Is it neocrystallization?
I'm sorry, that is incorrect. Orange, can you steal it? What was that? What? Phase change, yes. Yes, okay. Orange, here's your regular question. What is an earthquake? Yes. All right. All right, yellow. Oh, what do you know? What type of mountains form a convergent plate boundary with collision?
Fold thrust belt mountains and
Full thrust belt mountains, yes. All right, what?
Said she just would stop it right there, so you don't say anymore.
That's all you need. Green. Oh, look at your question. Here's your question. What is mass wasting?
Is that a material from the top of the slope to the bottom?
Yes. Okay. Blue. Rocks deep in the earth tend to be blank, which makes them more likely to bend in place. Rocks closer to the surface are colder and more stiff, which makes them more likely to blank. Okay.
Which makes them more likely to influx, while closer to the colder and more stiff, which makes them more likely to not break or stiff.
More likely to influx. Less flexible or Great. Okay. All right. I have 3 questions left, so I'm going to shuffle the deck to pick 2 more questions at random. This will be our last round. Okay. You can do the shit before it's good. So there's that one. And this one. Okay, and we'll shuffle those in. This will be our last round. Okay. And then I'll give you some notes that you can finish your homework. Okay, red. Read it now. There's 5 precursors of earthquake activity.
Foreshocks, change in electromagnetic properties, change in ground elevation, change in water levels, and changes in gases coming out of wells.
Okay, that'll work. Okay, orange. Aw, man, you guys are already having. I'm going to give you the same question twice. Some elements are removed from the parent rock and or some new elements are carried in, both resulting in the formation of new minerals not original to the parent rock. This result of metamorphism is a change in composition of the parent rock, and it's called what? Anybody can answer. Sorry, orange, you're out of time. Yellow, can you steal it?
metasomanism?
Yeah, just keep saying syllables until you can.
Okay.
Yeah, metasomanism. Yes. Okay, yellow, your regular questions. What is the difference between earthquake magnitude and earthquake intensity?
Magnitude is a way to describe the amount of energy released by an earthquake by examining the resultant.
Yeah, okay. Then what's intensity?
And then intensity scale is a way to describe the severity of an earthquake by categorizing the amount of types of resultant damage.
Yes. Magnitude is looking at energy release. Intensity is looking at the scope of damage. Yes. Something you give you a chip like this. Okay. I gave you the wrong chip. Green, here you go. What type of mountains form at a divergent plate boundary? Continental lifting. How ironic did you get this question? In fact, I should let you have that question, because you had it before. This one said, rearrangement of the atoms of the mineral crystal structure to form a new mineral with the same composition, but with a differently shaped crystal structure. What type of metamorphism is that?
This one is answered this one.
Yeah, this bill's already been answered.
So is the phase change?
Yeah, that is phase change.
I'm like, wait a minute.
Now, I'm going to have to, since the other questions you guys have answered too, I'm going to pick a different question. Okay, here we go. No. You already answered that. No, I mean, you specifically answered already. Alignment of grains and crystals into a common direction produces thin layers of bands. This result of metamorphism is a change in texture. That's called what? Foliation. Okay. And the last question. How does water contribute? Okay. A little, you got to keep a sandcastle. A little bit of water helps with cohesion. It helps grains stick together. The surface tension helps the material stick. Too much water blows everything apart. Too much water is going to drop your friction. It's going to act like almost like a lubricant. It can add mass, and it can cause expansion or swelling of material, which steepens the slope by pushing material out away from the slope.
Which is exactly what I said.
No.
I know the answer now.
You know the answer now. Okay, does everyone sign the attendance sheet? So go ahead and pass that around. Okay. Let's go ahead and see who got what here. Okay, let's see. Did you? All righty then. Okay, here we go. Red. Let's see what Red's got. Red's got 10. Okay. Orange has 8. Yellow's got a hefty pot here. Okay, that's close. Yellow has 15. Yellow's the one to beat here, people. Green's got 7. And blue's got 11. So green, yellow, you're the winners this week. Yay! Sounds quite that thrill. Ow, makes my leg working today. Alrighty, last time we were looking at some groundwater. And before we get to some groundwater problems, karst topography of all the groundwater problems that we have on the board, karst topography is the one that's naturally occurring. There are human activities that can make it worse and can accelerate it. But it's going to happen whether we do anything or not. Topography. You guys spent 2 weeks or almost 2 weeks in lab looking at topographic maps, elevation changes, the lay of the land, where are there hills, where are there valleys. So karst topography is looking at features developed underground. So it's looking at the topography underground. This topography is the result of acidic groundwater flowing especially through limestone. Now, most rainwater is going to be at least slightly acidic. As rain comes through the atmosphere, it's mixing with carbon dioxide gas, nitrogen oxide compounds, sometimes sulfur compounds, and that produces acids, carbonic acid, sulfuric acid, nitric acid. When it filters through the soil, it'll pick up additional acids that are products of the decomposition process, that are products of decay. Now, if you have limestone bedrock or limestone parent rock underneath that soil, limestone is made of calcite. What's calcite do in lab, in the acid bottle? It fizzes, it reacts, it's dissolving. So that acidic water coming through the limestone will gradually dissolve it. And over the centuries and thousands of years, and sometimes millions of years, that water is able to dissolve away huge openings through that limestone. Caverns, passages, tunnels, like Ohio caverns, Mammoth caves, Carlsbad caverns. This is karst topography. It's the only time when you can have passages large enough underground to allow for the free flow of water like we have on the surface with streams and rivers. Central and southern Florida has one of the world's largest karsted aquifers. That is the Floridian aquifer. It is a karst system that they get the majority of their drinking water from. Now, having those big openings means that you can accommodate not only huge volumes of water, but the rapid flow of huge volumes of water. So karsted limestones can make really good aquifers. But those big openings also allow for the input of more pollution and allows for the transportation and distribution of that pollution over a wide area very quickly. One of the hazards of karst topography is something called a sinkhole. Sinkholes develop, and they can occur slowly over time, or they can occur very rapidly and deadly consequences. Sinkholes form when these underground caves and passages get so big that there's not enough support for the ceiling, and it collapses. When that happens, you can instantly open up a hole in a matter of minutes that can be several tens to 100 feet or more in depth, and maybe several tens, if not hundreds of feet across. Just recently, the last couple of years in Florida, there have been several deaths attributed to the sudden collapse of sinkholes. It can be very difficult to detect ahead of time if you have the potential of sinkhole development in your area. Now, these sinkholes, they become more common or more likely in areas where you have heavy groundwater use. The water underground is helping to support those ceilings. If you have groundwater mining and more water is removed than nature can refill it, when your water levels drop, you lose some of that support, and that can make the collapse of these features more likely. Of course, Florida is seeing a huge problem with this because they sit on an aquifer that's karsted, and their population is increasing. So they have more people building homes and structures and roads on top of these ceilings. And because of the higher population, they're using more groundwater. They're kind of walking a razor's edge here with safety. There's really no way that you can fix these. It has been attempted in the past to pump them full of cement, but it's actually kind of fun to watch engineers try to do that. But you have to remember how they formed. They started as a passage from water flowing through. So that one hole is probably connected to tens of miles of passages underground. So yeah, you can fill it with cement and wait a few minutes and listen, and you can hear the cement getting sucked into other passages and caverns, and the whole thing will drain. Yeah, so not a good fit. Sinkholes in the past have been used as disposal sites for industry and municipalities. And in the past, they were huge sources of groundwater pollution and contamination. Now there are more strict regulations on what you can or cannot put down a sinkhole. Again, it's coming out of ignorance, not realizing that there's groundwater flowing through there, and anything you put down in the hole will get picked up by the groundwater and spread to the whole system. Any questions? Dying to know about deserts. I know you just can't wait.
Really more about flash floods.
I know.
That's one thing that really gets to me.
That's right.
So groundwater wraps up our look at the hydrologic cycle. So now from feast to famine, we go from groundwater to deserts. I know, that'll come later. We'll get enough of that later this week. So a desert, to be a desert, most people that have seen the movies, Arabia and all that, they're going through the desert and it's so hot and dying of thirst and, the buzzards are circling and the camera shoots up, look at the sun and it's so hot. And hot is not a criteria. Hot does not make a desert. Dry makes a desert. Deserts are called that because they get less than 10 inches of rain and or snow a year. That sounds like a lot of water, but it really isn't. Over 365 days? Nothing. If Florida has a big hurricane come in, Category 3 hurricane can dump up to a foot of rainfall over half the state of Florida easily in less than a day. So 10 inches is nothing.
We've had, what was it, last winter or the winter before? How much inches of snow did we get?
Total, I think last year was almost 3 feet. It was over 25, 26 inches. Yeah, that was just snow.
And on the Big Island of Hawaii, on one side, they get 222 inches of rain a year. On the other side, they get 20.
It's desert, yeah. Because the mountains don't like the rain. We'll get to that.
Does it depend on which desert you're talking about, though?
As far as what? Rainfall? That is the number one criteria to designate an area as a desert. Now, can you get more than that per year? Yeah. But on average, you're going to get less than 10. In many desert areas, you don't get any at all. You may not get any rainfall for several years at a time. But when it does rain, then you get problems. The number one hazard in desert areas, like Arizona, New Mexico, Southern California, is actually, wait for it, flash flooding. Flash floods in desert areas kill a lot of people annually around the world. It's kind of a contradiction in terms. I just told you, they don't get any rain, and then I tell you they get flash floods. Well, we get flash floods here too, but it doesn't really kill a lot of people annually. There are reasons. What are the four main reasons that flash floods occur in deserts? One, when it does rain, you get it all at once. So you often get high volume of rain in a short period of time. That 10 inches of rain or snow is coming from a really strong storm system that has a lot of precipitation and a lot of wind and a lot of oomph to have the power to get that far in the desert and rain. Not too often. But when you do get it, you can get several inches in a matter of hours or less. Now we get that here, we can get flash flooding too, but who cares? Because the warnings come out, we know where it's going to go. Why do we know where it's going to go? Because it rains here more often. And when it rains here, as often as it does, then the rain hits the ground, it flows along the ground, it carves a little groove into the dirt, and forms a channel. We have streams. That stream's job is to drain excess water off the land. So when we get a flash flood, we know it's going to be in the creek, it's going to be in the stream. Stay away from the stream. Deserts don't have that. Because it doesn't rain that often, deserts have very poorly organized drainage, if they have anything at all. So when rain hits the ground, instead of like, oh, there's the stream, I'll go into the channel, rain's like, where do I go? Where do we go? Where do we go? I don't know. I'm going over here. Where do we go there? I don't know. I don't see a stream. Do you see a stream? I'll just go this way. There's no pattern. There's nowhere to go. So it goes wherever's downhill. No organized drainage. You know, you can find an old riverbed or an old stream bed in the desert, but it's not like around here where you can follow it downhill to a river, to a bigger river, and a bigger river. You can follow a river channel, an old dry creek bed in the desert, and you'll follow it and it'll just stop. Where the hell did it go? It's just gone. It doesn't connect with anything. So when that rainfall hits, it goes wherever it's most convenient. If most convenient is down Main Street or Reno, that's where it's going to go. You go out west, especially in the southwestern states in California, you'll find the big cement culverts, big cement like the Los Angeles River. You know, they have all the movies and TV shows in the big concrete ditch. Okay? They built that in order to give those areas drainage that doesn't exist naturally. In the 1920s, 1930s, and 40s, Los Angeles used to flood badly every year. It would kill several hundreds of people. That's why they built that channel.
Why would they have one like that in Cincinnati, you know? Is it because close to the river or what?
I have no idea.
They got one of those things in Cincinnati.
I'm not sure which one you're referring to. Definitely they need improved drainage because high rainfall in Cincinnati leads to slope failure. Cincinnati leads the nation in monetary losses due to mass wasting. Just hard to imagine you think California, but no, we're number one! Yeah, because of the rainfall. Number 3. Around here, it rains a lot. We get vegetation. We have grass and trees and shrubbery. That vegetation absorbs, it soaks up a lot of that water, stores it. And as that water is flowing along the ground, it breaks up the flow. It slows down the flow, spreads it out. You don't have that in the desert. Many vast regions of desert have no vegetation at all. Because it doesn't rain that often, you don't have a lot of vegetation. Because you don't have a lot of vegetation, you don't have good soil development. In desert soils, you get caliche. You get those hard, dense, concrete-like layers of calcite in the V horizon. When's the last time you went out in a parking lot in a rainstorm so you could watch the rain soak into the cement? It doesn't. It flows across the parking lot into the drainage system. That rainfall is going to hit that caliche and do the same thing. It can't get through it. So rainfall in the desert, in many cases, can't soak down into the groundwater. It's blocked by that caliche. So it just flows across the surface. That O horizon, that organic layer, organic material can expand 10 times its volume with water. It becomes a sponge. You don't have the vegetation, you don't have the organic layers in the soil, you don't have that. So all that rainfall just goes wherever it wants to. Are there any questions? So we need deserts to be dry. Well, where can we get these dry conditions? One. We'll start with the subtropical belt. Around the equator, approximately 30 degrees north, which passes right through the Sahara Desert, and approximately 30 degrees south, which passes through the deserts in Australia. We have sinking air. That's because air at the equator gets pretty doggone hot, and it rises. The air rises, it cools. Colder air is heavier, it's going to sink back to the surface. Well, that colder air starts sinking back to the surface around about 30 degrees north and 30 degrees south. Sinking air hits the ground and piles up at the surface. Sinking air will not form clouds. To form clouds means rising air. Think about our weather patterns. When we're under a high pressure system, we usually don't have a lot of clouds. With a bright blue sky, it's very warm. Because the high pressure is pounding all the air in the ground. The air is sinking. When do we get the sinus headache and the dark clouds roll in and the low pressure system comes in? The low pressure draws air up from the surface of the vacuum. And that rising air draws all the humidity with it, and you get clouds and essentially precipitation. Rising air gets colder as it rises because it's expanding. There's more room up there the higher up you go. Sinking air is going to compress, and as it compresses, it'll warm. Warm air can hold more moisture. We all know that. Around late in August, when it's like 85,000 degrees outside, 200% humidity, and you feel like you need gills to go outside. Warmer air holds more moisture. So when that air sinks, and it compresses, and it heats up, that warm air is going to be able to evaporate whatever moisture is on the ground and maintain that dry condition. And with sinking air, you're not going to get clouds. You can get coastal deserts, like Southern California, South Central Mexico, much of the west coast of South America. Offshore, there is a cold current. That cold current makes the air above it cold. So when wind blows across that cold current onto the land, it's blowing the cold air onto the land. We're coming into winter. Anyone turn on their humidifier yet at home? Yeah, I mean, why? Your hair's getting brittle, your skin's getting all crusty, you're getting electrocuted on every piece of metal you touch, like a light switch or the bed frame. Too much static. Air's too dry. Cold air does not hold moisture. So if you blow cold air across a cold current, it's going to be dry. And you look at a cold coastline. And a dry coastline. What else we have? Let's see, we got trees, we got continental interior. Continental interior deserts. Like the Gobi Desert, Mongolia, Upper China, Northern China, parts of the Sahara, areas deep, deep, deep within the continent, very far from the coastline. Parts of western Texas, the western southwest of the United States, continental interior. Remember we had Mexico had that really nasty hurricane not too long ago that came up, and we got some rain from it even. It came terror acts right through Mexico, and came through western Texas and hosed them and hosed us. And some of them back in October. Yeah, that's really the only time those areas get really good, strong rainfall. Because they're so far from the ocean. By the time clouds and storms get that far inland, they're spent. They have no water left in them. They don't have enough humidity to rain anything out. They're dry. They're done. So you get very dry interiors in your continents. other parts of the desert southwestern United States, Death Valley, California, many parts of Mexican desert, places throughout the Rocky Mountains. Some of your mountain valleys are deserts because of rain shadow. Hawaii, rain shadow desert. You have tall mountains. Wind comes in. Where else is it going to go? It's going to go up over the mountains. Wind goes up, rises, cools, and you get clouds. You get rain, and at that elevation, most likely snow. But those mountains are kind of like the first hill on a roller coaster. When that air comes over the top, it's going to fall down the other side. So down on the other side, you get sinking air that's warming. Your clouds are going to fall apart. All of your air is going to pile up here at the surface, and you'll get desert. So in the shadow of the mountains, you get no rain. Many parts of Arizona, Nevada, New Mexico are rain shadows. They're in the shadow of the Southern Rockies, Camelbacks for Arizona and New Mexico. You need a really strong storm system to get rain over those mountains and into the desert behind them. You've got to be really careful where you camp in the desert. A lot of times you'll have, near the mountains, you'll have deep canyons where you can find water, which is a great thing to find in the desert if you're dying of thirst. But the water's there because of flash flooding. And those canyons are carved by floodwater. Many times people camp in them because they're cool, they're shaded, they're out of the sun, and they have water supply. And if it rains overnight in the mountains, the next thing they know, they got a 15-foot high wall of water coming 40 miles an hour down the canyon, and they got nowhere to go. You have to talk to me. Let's see, so that's 1, 2, 3, 4. Last one, 5. Polar regions. Up the North Pole, most of central Antarctica. Now, much of Antarctica is continental interior desert as well, but it's also very, very cold. It's down at the South Pole. What happens is, even though you have temperatures well below freezing, sometimes 100 below or more, plus with the wind, it's too freaking cold to snow. The air does not have the capacity to hold enough humidity to make clouds, let alone rainfall or snowfall. And that keeps those areas very, very dry. Some of the snow, a lot of that snow in central Antarctica has been there for millions of years. Any questions?
Kind of makes sense though, just think about it. Like when we had the bad weather last year, snow stayed forever, it just never got warm enough to just thaw it out.
Now, thawed out. And in some cases, if it gets cold enough, it'll actually, what they call sublimate. It'll go from solid directly to vapor, directly from solid snow to humidity, to vapor. It won't melt. Yeah.
So like, that's kind of a weird thing. So like in Afghanistan, where some of the mountains are, even though they're high in elevation, that occurs. That's why you get a lot of the snow on one side, but
dry on the other. You got nothing.
Desert, no rain, but you can see it like in the mountains. You can see that it's a little more.
Yeah, they're in a rain shadow. Yeah. Any other questions?
It says on the blue side or the north side.
Okay. Windward means you're facing the wind. Lee, that's not that. We didn't name that. Those sailors came up with those names. Can't blame us for that. Lee is on the back side. Yes. Yeah. This is Lee. Leeward, and this is windward.
Thinking areas on the lead side?
Thinking areas on the lead, yes. So now I'll need homework 11 by 2 o'clock. Jack is over here by the podium. You got